Well, it's my pleasure to introduce our first keynote of the morning. 20-something years ago, here at Bioneers, the ethnobotanist and self-described plant person Kathleen Harrison described the worldviews of the indigenous shamans and plant people with whom she was working in the Amazon. She said this: "Everything is vibrantly alive in the same way we feel we are. Every single species has eyes with which it sees the world, and it sees as legitimate and true a version of the world as what we see. Every species has a song. It's part of an encyclopedia on the sonic level in the same way the seeds are on another level. As a species, it has a vast set of relationships to all the others in its world and to its ecosystem. These plants are allies to each other. They're also not allies. It's a net of species that are communicating, and we're each just beads on a net. In these traditions," Kathleen concluded, "the spirit resides in the species, and every species will speak to you in the same way from the same source. Take away your identifying mind and just see the spirit in the plants." Over the past 20 years, there's been a revolution in vegetal biology. Scientists are starting to talk like shamans, and shamans are starting to talk like scientists. Where previously science has regarded plants as inert mechanisms, research scientists are now proving in the lab what shamans have long observed. Plants are animated with intelligence and consciousness. They learn, remember, communicate, and have intentions. In fact, they do most of the things we associate with personhood. Monica Gagliano is a research scientist operating on the far frontiers of plant cognition to reveal them as sentient organisms. She's done so by combining the objectivity of the scientific method with the subjectivity of intuition and transcendental experience. Michael Pollan reported on Monica's rigorous research in The New Yorker, and Michael originally referred Monica to us. Monica believes she was born to be a scientist. As a girl, she grew up in the city. Her parents thought nature was dirty. You didn't touch nature and you kept it outside. But of course, she didn't. She started a journal tracking the growth of her bean plant and created her first data set at age 9. Monica's a research associate professor in evolutionary ecology at the University of Western Australia and a research affiliate at the Sydney Environment Institute at the University of Sydney. After studying animal behavior as an animal ecologist, she turned her attention to plant behavior. She's penned numerous groundbreaking scientific articles. She's co-editor of The Green Thread, Dialogues with the Vegetal World, and The Language of Plants, Science, Philosophy, and Literature. Monica's new book is Thus Spoke the Plant. She calls it a phytobiography, a collection of stories written with and on behalf of the plants themselves. She describes her imaginative experiments that opened the space to begin to understand how to make contact with this other than human intelligence, in its own language and on its own terms. Among other experiments, she's blazed the trail for a brand new field called Plant Bioacoustics, showing that plants do make sounds, or shamanically speaking, you might say, plants do have a song. Monica's illuminating the forefront of a new scientific paradigm. She recognizes and respects the other-than-human genius of nature. She dissolves our false separation between people and the natural world. She seeks to learn the languages of nature, and she quiets her identifying mind to see the spirit in the plants. Please join me in welcoming a plant person supreme, Monica Gagliano.
Okay, so first of all, I'd like to, acknowledge the traditional owners, and also as I was listening to the welcoming ceremony, I just realized that I should also honor the indigeneity that lives inside me and inside every one of us, because we are all indigenous of this place. So So I'm going to start with a little talk. It's actually a little anecdote of something that happened to me just a couple of weeks ago while I was in Brazil at a conference on plant physiology. And after the sort of introductory plenary talk, we had nibbles and drinks, and one of my colleagues, a philosopher, asked a very simple question to a group of us. And so I'm going to pose the same question that he asked here to you. And the question was, what killed the dinosaurs? And I'm sure that the first thing that comes to your mind, which is the same thing that comes to everyone's mind, is like, but of course it's the asteroid, right? And in fact, we know very well an asteroid collapsed onto our planet and put up this big dust of sand and dirt, and it covered the sun, and then, it got really cold and everyone died. And in fact, that's how the story goes. And in fact, we also know that at that particular time, it seems that many species disappeared. And so it kind of corroborates the idea that, well, there was one single cataclysmic event that kind of wiped everyone out, the asteroid. And then in 1978, in the peninsula of Yucatan, we found this huge crater. And so that was the cherry on top of the cake. He's like, well, that's the asteroid. Now, of course, I'm not here to debate whether the asteroid that was charged with the killing of the dinosaurs really did a good job, did the job at all, or not. But the reason for putting up this question, which was really the same reason why my colleague asked it at the conference, is that when you're asked to think of an alternative explanation that is not the story of the asteroid that you've been given since you were at school and before, possibly, we find it really hard to think of something else. But it is the asteroid. What else could it be? And so the point of this is that pretty much by the time you go to school, so by the time you turn 7 or thereabout, your imagination has been already stifled. And your actual ability to think of alternative possibilities is reduced dramatically. And so I'm going to talk about the role of imagination in the context of science, but it's just an example of what it really means in the wider picture, especially in the context of the wider picture that we are experiencing right now. So imagination, from the roots of the word, it means create images of something, or representing something, representing the world. And of course, we all know our imagination touches and deeply moves us, especially when it's expressed through creative approaches that artists and musicians, for example, are really good at. And so what I find intriguing is that basically imagination is the creative ability of our mind to literally dream the world and worlds. And so it's a bit surprising that such a critical, creative endeavor would be kind of dismissed when we talk about science. When we talk about science and you talk about imagination in science, the word takes a totally different meaning. And suddenly you're talking about like fanciful, speculation of empty assumptions. Basically, they're telling you, what are you talking about? There is no such a thing. So there is either a tendency to kind of downplay the role of imagination in science or completely dismiss it from the important role that it has in the construction of knowledge through science. So I'm not here to, lay judgment on science. But it is true, though, that our modern techno-scientific world has kind of subscribed to an arid version of imagination. And it's very different and very far away from what we know imagination is when we think about it as the creative beings that we are, because we are all artists, we are all musicians in some ways. So what I was interested in is when science, which is a strong voice in our culture still, when science describes a world that is kind of deprived of imagination, then you're describing the human and the rest of nature as a system of cogwheels. And suddenly, those parts are easily to dispose of. They are, replaceable. And in the worst cases, and we see this all the time, they become worthless. So again, as I said, I'm not here to pass judgment on science. I'm a scientist. I love science. And I think science is yet another amazing creative endeavor of the human experience. So what I'm interested in is how we actually got to stand in front of this door and why we are so scared, especially in science, to open it. Because I have my little theory. For me, the idea of imagination, of course, brings up like this feeling of unruly and out of control. And in a world that we feel increasingly unsafe, and we, as a counterpart, we feel like we need to control. The more we control, maybe we have the illusion that we will feel a little safer. But actually, maybe it doesn't work that way. And maybe, we're standing in front of this door and we are so concerned that if we open it, we are going to unleash chaos. But in fact, maybe imagination can release those solutions that we are so desperately looking for, and we can't see them, just as we couldn't see an alternative to the asteroid for the dinosaurs, because we've been trained and conditioned to think that that's going to be chaos if you open the door. So I'm going to bring up one of the most impressive scientists of the most recent years, decades, and of course it's Darwin, which has guided a revolution of his own. And he recognized the role of imagination. Actually, probably many scientists wouldn't be able to do their job without it, whether they like it or not. And so Darwin recognized that imagination actually is a prerogative of the human. I corrected that. He said man, but... And not only that, I corrected again, I added a S. It's a faculty that allows us to actually create the brilliant and novel results or opportunities that we are all looking for. So, why imagination is so important and why it's actually not that difficult? Because it represents a reservoir of meaning. And this is a meaning that is embodied. It's in our flesh, it's in our blood, it's in our roots. And not only that, but it's it's made of a pre-linguistic system. So we don't even need to talk. We have it. We can feel it through our emotional system. Our body knows it. So it's kind of like a birthright. How lucky is that? We're so desperate for solution, and the solution is right here, inscribed in the system itself. So pretty easy, right? But from a Darwinian perspective, or from an evolutionary perspective, well, the reason why this information is so important is actually because it does guide action and adaptive behavior. So those are the solutions that we want, because another way to say this would be that is the innovative solution to the eco-cultural and also political issues that we're having at the moment. So the question would be like, okay, great, I'll subscribe to that. How do we open the door? And all I can offer, because I don't think that there is one solution for all I can offer is my experience as a scientist and also my own personal journey when I chose to open that door for myself, and also what it means when you can extrapolate from that smallest story of the individual to a bigger picture of a collective. So when I opened the door, I found two things. I found plants and indigenous knowledge. And of course, you probably know from the introduction that Kenny gave, I was studying animal behavior, and then I decided to switch on to plants, and that's a story of its own. And when I started looking at plants, I looked at plants from the context of plant in relation to sound. And that was totally inspired by my own experiences in the realm of indigenous knowledge, where this story has been recurrent everywhere. And so my role, I felt, was just to see whether science could actually test it. Isn't that what science does? It tests ideas. And of course, that in itself was scary enough, so that I had a couple of colleagues in my own corridor, in my own department, that couldn't bear saying hello to me for 2 years. I know. But that is just a small example of what it means, how scary it is to actually open that door. But what do? we just open it anyway, right? So, and actually then you get really good at it, and there's a little bit of audacity that kicks in. And so, oh yeah, this is really disturbing. There must be something in here. I'm going to push even further. So I moved from just the communication of plants to something that it got perceived even more threatening. And that is like the entire area of the cognitive abilities of plants. And of course, learning and memory under that umbrella. So I need to give a little story here again because, of course, research on learning and memory comes from the domain of psychology. So it comes from the study of the human cognition. And then in several decades later, we managed to move beyond the human and include some animals. And then more recently, even machines. But one thing that this entire field has been insisting on is the fact that neurons and brains are the key. And if you don't have them, you are automatically a priori excluded. Which, of course, when you actually then explore this, you realize that that's not true. But in order to do good science, you go and do your experiments. So the first plant that I worked with is Mimosa pudica, also known as the sensitive plant, because it moves really fast, literally at that speed, or even faster. And the reason why this plant is being loved forever, literally, there are records from the Roman time. Darwin was passionate about mimosa. And then you probably have known and seen about her from a beautiful article that Michael Pollan, which is somewhere around, wrote a few years ago for the New Yorker, where mimosa was featured, and Michael did a really good job at describing one of the experiments that I did with these plants, which included like dropping the plant and see whether the plants could learn to ignore me, basically. And it does. It learns really fast, and it remembers for a very long time. But I'm not going to go into mimosa because I like to spend some time to talk about a kind of higher level of learning, which is from a pea, the nice, humble, green garden pea. Now, to understand what I did with the peas, we need to go back to the animal kingdom. And I'm sure that many of you are familiar with the Pavlovian study of the dog. So just to, go briefly through it, Pavlov noticed that, of course, dogs salivate when they are about to receive their dinner, and they're getting very excited. And then he wanted to know whether he could kind of manipulate that behavior. So the salivation of the dog to dinner is instinctive. Dogs do it. So then he needed to find some neutral cue that he could use and see whether he could change that response. And he turned up with this bell. And so the story goes that whenever he rang the bell and then presented dinner, the dog would salivate. And then, because the dog learns about the relationship between these two things, the bell and the dinner, and the fact that the bell predicts the arrival of dinner, then the bell on its own suddenly is producing the salivation of the dog. And so what is interesting about the experiment is the fact that, first of all, the dog is evaluating what's going on in his environment, and he's got his own value system. So he's deciding what he wants, what is worthwhile, what is it going to help him to get there. Now, the next thing about this is that, of course, not all dogs are the same, and so this value system is very subjective. So there is a subject in there, and then that is making these decisions. And the decisions are made on feelings, depending on how the dog feels about having that dinner or that dinner, and about this bell. It could be really annoying. But also by the experiences that are connected to those cues. Now, the really interesting thing about this experiment, from my perspective, is that, in a way, by salivating to the sound of a bell, which really, because it's predicting dinner, what the dog is showing us is that he's actually extending the amount of information that is in the environment. In other words, he's extending the information to something that is not in the environment, because dinner is actually not there. So food, or dinner in this case, is just a concept in the dog's mind. Or in other words, the dog is imagining dinner Now, take this and let's apply it to a plant, exactly the same strategy. So dinner for the plant is blue light. And this response, the plants don't salivate, but not for as much as I know, but blue light it triggers a phototropic response, which means that the plants will bend towards it. So that's what the plants want, just as much as the dog wanted dinner. Now, I had to find something that would replace the bell, but would play the same role. And what I came up with was this little tiny fan, which on its own doesn't do anything to the plant. The plant actually doesn't really care. So it keeps growing straight, hoping for some light somewhere. Now, just as Pavlov did with the dog, if you present the fan, always anticipating the light, eventually the plants learn that actually, just by the fan, I can start preparing and turn towards it because the fan tells me where the light is going to be. So, of course, just like for the dog, there is someone in there who is making the decision. And it's based on a value system. How much do you want that light? What does the fan mean? And just like for the dog, not all plants are the same. And also, that subject in there is, deciding and choosing based on how it feels about things and the experience of those things. Just like for the dog, the plant is actually stretching the field of perception because dinner, in this case the light, is actually not even there. So you know where I'm going. So just like the dog, the food is actually a concept, an idea in the plant's mind. Or, in other words, the plant is imagining the food arriving. So this, of course, was a great study. This was a great study because, apart from the results, the scientific results, it was able to disrupt, that linear thinking that, if you don't have a brain and no neurons, you can't have this. And he says, no, it works some other ways. And so we had to relinquish that or at least expand it. And but the other thing that was good for me personally is that basically it showed me that imagination is everywhere, no matter what kind of mind or what kind of form you are. And so, in other words, it would be the same as saying that imagination is at the heart of nature, our own nature as the human form, and any other nature. And equally, it's an important bridge between that heart and the mind that dreams the world into being. Again, whether it's the human mind or not. Now, do you remember this door? We are stuck in front of this door, and we are so concerned that if we open it, we are going to unleash chaos. But guess what? By staying behind this door, which means we are staying stuck inside our minds, and we don't want to cross that bridge of the imagination that can link our mind to our heart, we are actually experiencing chaos. I'm sure everyone's seen the IPCC report from last week, and it's not exactly great news. But the good news is that we don't have to do this. It's just as easy as opening the door. All we need to do is there, so that connection can be reestablished. It's already there. We just have to open the door to it. Now, again, just to finish, in my own personal life, when my mind, and I'm so happy that I have one, and my heart, and I'm so grateful that I have one, were linked together through the bridge of imagination, I discovered a few things. One, that it took me over those intellectual gaps that I was so afraid of, so the fear of opening this door. Two, that it has integrated what it looked paradoxical, what looked like discrepancy between what I knew and what was to come, the new. And then it allowed for the emergence of this new insight, new understanding, and inspiring ideas. And basically, it changed my life and my world as the individual. But it also showed me that it's absolutely, without a doubt, possible. We can do it, and we just need to dare. Thank you.